Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 6, Chapter 2, Building Software, the View from 30,000 Feet, Part 2.
So here are some things to keep in mind. First, you should assume that your developers do not know your business or your needs and pains, your customers or their needs and pains, if those are what are being solved, or anything about your industry or that of your customers. Second, you should, as in you had better be able to, assume that your developers do know the proposed technology stack. Note that the right technology stack cannot be projected until the scope of the project's requirements is known. One mistake often is that developers are hired before the project is defined. They then define the project in terms of the technology they already know, rather than defining the project in a technology agnostic way, and then finding the right combination of technologies that most efficiently and effectively solves the problem. The law of the instrument is, if the only tool you have is a hammer, it is tempting to treat everything as if it were a nail. It's attributed to Abraham Maslow. Your developers should also know more or less computer science and or software engineering. They should have or know a defined software development process and be practiced at using it. All the developers need to use the same development processes and have the same project discipline. And all the developers need to know how to use the standard tools that will be used in the development and test of the system. Developers should also have experience building applications like the one you are asking them to build. Lacking direct experience, they need to have relevant related experience. Lacking even that, any estimates they provide should be treated as best guesses until proven otherwise. Finally, you must realize that the overall goal or objective is not the production of a software system, but the solution of a problem. The conundrum is that handling these issues can be expensive and time-consuming and have the most leverage earlier in the process when there is often little or no capital to invest in sound engineering processes. A balance must be struck between having a full ceremony process and being able to afford any development at all. The solution is for the founder and or manager to ensure that enough of the right things are being done to avoid the obvious project failures and create a sustainable product. This is a crash course in how to do that. You have to survive long enough to have the wherewithal to pay down the technical debt you will incur in the early stages. Surviving by piling up a mountain of debt, technical or financial, creates a long-term existential risk to the enterprise. There's no guarantee of success, but we can provide you with the tools that give you a chance to succeed. Software is always part of a larger system. That ties its development closely to systems engineering, which looks at the entirety of the system under development. To be done well, software projects should include some or all of the following tasks. First, analyze the application to determine the requirements that must be satisfied and record these requirements in a detailed, well-organized, easy-to-use document. Second, participate in designing the computer system configuration, determining which functions will be implemented in hardware and which functions will be implemented in software, and selecting the basic hardware and software components. Third, analyze or simulate the performance of the proposed design to ensure that it can meet the application's requirements. Fourth, design the basic structure of the software, its division into modules, the interfaces between these modules, and the structure of the individual programs, documenting all significant software design decisions. Fifth, analyze the software structure for completeness, consistency, and suitability for the intended application. Sixth, implement the software as a set of well-structured and well-documented programs. Seventh, integrate the software into existing off-the-shelf or free and open-source software. Eighth, perform a systematic and statistical testing of the software in an integrated computer system. And ninth, revise and enhance software systems, maintaining their conceptual integrity and keeping documents complete and accurate. Agility, so-called. One of the software development process improvements that has evolved in the recent-ish past is the use of agile techniques for development. Combined with wholesale reuse of software components, including free and open source software, and mature definition of APIs, agile methods, for example Scrum, encourage incremental development, a process whereby complex software grows organically from simpler systems. The rapid turnaround implicit in agile techniques gets immediate feedback from the customer base, improving the application's functionality from the consumer's perspective. Difficulties may develop, however, when a minimum viable product (MVP) strategy is pursued. depending on how minimum. If the software is developed rapidly and with little regard for the quality, then a day of reckoning will surely come when the developer's ability to add or enhance features is so hampered by the defective nature of the code as written, and worse, deployed, that new features and bug fixes slow to a crawl, if they move at all. All successful software gets changed, so change should be expected and anticipated. Precisely what changes will be requested cannot be known, but the fact that changes will be requested is a certainty. Failure of software projects is almost always a failure of management rather than technology. Most programming tasks do not need to, and are not intended to, stretch the boundaries of what can be computed. That sort of thing is usually relegated to research being done in universities. A quote from DeMarco and Lister: "Since the days when computers first came into common use, there must have been tens of thousands of accounts receivable programs written. There are probably a dozen or more accounts receivable projects underway as you read these words. And somewhere today, one of them is failing." Close quote. Even when the problem at hand is completely understood and the technology well known, the result can be a complete and unmitigated disaster. That can be you and your project if care is not taken to lead the project well. The larger the software system being built, the more likely it is to have challenges, so keeping a project small can help here. Software development is a team sport, however. A small application, a simple game for a mobile device, let's say, can be and often is developed by a lone ranger. A solitary programmer might develop a larger system, but a lone developer is likely to make coding errors that are uncaught by testing, because when a developer tests their own code, they do so with the same biases they developed it with. Their code is also guaranteed to be idiosyncratic and difficult, therefore, for anybody but them to maintain. It is possible to throw an MVP together using a solitary programmer, but once the system starts getting used, it will need to be upgraded. No developer is truly a master of all trades, claims of full-stack capabilities aside, and they will often miss important aspects of the system that others with different training and experience would be able to foresee and therefore avoid. What cannot be avoided is the rework necessitated by replacing and rewriting the idiosyncratic code base so that it can be carried forward.
That ends Chapter 2, Building Software, the View from 30,000 Feet. Join us next time for Episode 7, Part 1 of Chapter 3, How and What to Organize, Life Cycles and Teams. That's it for me for you for now. Be careful out there. Bye.